What if you could build a real quantum computer at home? No cryostat. No laser safety officer. No $50,000 setup. Just a permanent magnet, a copper coil, and some nuclear physics. This is NMR-based quantum computing. Hazard-free. Room temperature. Under $500. Let me show you exactly how it works. Every DIY quantum tutorial online has the same problem. They start with NV centers in diamond. And then casually mention a class 3B laser. An avalanche photodiode running at 400 volts. An optical table. A laser safety officer on site. Minimum bill of materials starts at $5,000. I tried this path. It is not home lab safe. One misaligned optic and you destroy your eye. One wrong connection and the APD shorts. There has to be a better way. Nuclear spins are quantum bits. Every hydrogen atom in ordinary water has a spin. Every fluorine atom in a fluorinated molecule. These are natural qubits. To initialize them you apply a static magnetic field. A permanent neodymium magnet. The spins align into two energy states. Spin up and spin down. The energy gap is in the radio frequency range. 1 to 100 MHz. Gates run at milliwatt power. Not gigawatt lasers. No cleanroom. No special safety equipment. This is nuclear magnetic resonance. It has been around since 1946. We just never thought of it as a quantum computer. Here is the direct comparison. NV centers require a class 3B laser for initialization. NMR uses a passive permanent magnet. NV gates run at 2.87 GHz microwave pulses. NMR gates run at radio frequency. The difference in power is enormous. NV readout needs a single photon avalanche diode at hundreds of volts. NMR readout is a copper pickup coil and a low noise amplifier. NV center minimum cost is $5,000 to $50,000. NMR DIY cost is $100 to $500. The commercial SpinQ Gemini gets you 2 qubits for $15,000. The Hackaday community-built Earth-field NMR for under $100. The trade-off is qubit count. NMR tops out at around 7 qubits. But for a home lab that is extraordinary. Here is where the build currently stands. I am going to be completely honest about the problems I have not solved yet. Problem 1. Field homogeneity. My NdFeB permanent magnets give 500 parts per million field variation. I need better than 10 parts per million. That is a 50 to 1 improvement. Off-the-shelf magnets do not get there. Problem 2. J-coupling readout. Signal to noise on the pickup coil is borderline. I can detect the NMR signal but the J-coupling splitting needed for controlled NOT gates is buried in the noise floor. Problem 3. Ambient EMI. Wi-Fi routers and switching supplies overlap my signal. I need a Faraday cage. These are real engineering problems. I am stuck on all 3. I have 3 specific gaps where I need help. First is magnet shimming. If you have expertise in permanent magnet array design or precision shim coil winding, I want to talk to you. Second is low noise RF electronics. I need a preamplifier with noise figure below 2 decibels at 50 to 60 MHz. If you have analog RF design experience, this is your territory. Third is funding. The SpinQ Gemini Mini is a commercial 2-qubit NMR system at $15,000. Between a $100 Earth field spectrometer and that commercial unit, the gap is exactly where this build lives. Tell me in the comments. Subscribe for the full build log. Every problem I hit. Every solution I find. If you can help push this further, comment below. This quantum computer will get built. The question is, who builds it with me?